All right, in this video, we are going to talk about problem 4.150. It's about dice. It says two balanced die are thrown, one red, one black. What is the probability that the red die comes up 1, given that A, the black die comes up 3? All right, so we want the probability of a 1, a red 1. Okay. Given that the black die comes up to be a 3. All right, so that's what we want. A red, what's the probability of a red 1 given that the black die comes up 3? All right, and so to make this problem a little bit easier, right, what I've done is just I've drawn the sample space out, okay? So this is the sample space for the entire problem, and I'm going to have to draw on this. So let me take a picture of it. All right, so what we want is the probability of a red 1 given that the black number comes up to be 3, right? So probability of a red 1 given black 3. So you can use the conditional probability formula on this, right? But we have a nice picture of our sample space. So I'm just going to do it by looking at the sample space itself, right? So first off, let me switch colors here. So we are given that the black die has come up as a 3, right? And so we're going to, that's basically becomes our sample space. So if you look, right, at that, all the rolls where the black die is a 3, right, you come up with these 6 right here, okay? And so now we're going to limit our attention only to those 6. So the bottom number, right, on the on here is going to be a 6. All right. And so then what we're going to do, right, is count how many rolls are there with a red 1 that are in this group right here. And you can see there's only one, right? And that is this one right here, right? So we're going to go through all of these that's now our sample space, and we're going to count up all the ones where we have a red 1. And we can see that there's only one of those, right? And so therefore the probability is 1/6 on that. Okay. So before, right, we were, when we were doing some of these before, we were looking at all the elements of R1, right, of this first event, right, in this case R1. That would actually be all of these ones in this column right here. And then we were figuring out how many were in this other event here. And you can see it's only this one right here. Right? All right, so let me clear that out. Nope. All right, next one. In part B, they want to know what is the probability that the red die comes up to be a 1, right, given that the sum of the dice is 4. Okay? So probability of a red 1 given that the sum of the dice is 4. All right, so what I'm going to do then is to look at all of the rolls here, right? This is my sample space, all the ways I can roll outcomes that can happen when I roll a red die and a black die together, right? And so I'm going to look at all the ones where the sum is 4. So you can see right here 3 and 1, right? And 2 and 2, and and 3 and 1 right here, right? So you can see that's all the possibilities where the sum of the numbers, right, are equal to 4. So that becomes our sample space, right? So what that means is that the bottom number, right, on our calculation is going to come out to be a 3, right? So that's S4, the number of things in S4. And then R1, right, is going to be this, right, where the red one comes up to be a 1. So that's going to be R1. And what we would do, right, is to count up how many of these elements of R1 are also in S4, right? And you can see there's only one, right? It's basically the intersection of these two. And so that would mean that the top number, right, on here would be a 1. So that's part B, 1/3. Okay? All right, next one. It says, in part C, they want to know what is the probability that the red number comes up a 1 given that the sum of the dice is a 9. Okay? So probability of a red 1 given that the sum is a 9. All right, so let's pull up our picture of the sample space again. And let me erase all of these old ones. All right, and now we're going to do the sum is 9, right? So right here you can see I have 6 plus 3. And then it kind of goes up the diagonal. Right here I have 4 and 5. 5 and 4. And 6 and 3. All right, so you can see I have circled all of the outcomes where the sum, right, is equal to 9. Okay. All right, and next up is R1. That's the event that the red die comes up to be a 1. And that would be all of these, right, again. Okay, so our sample space, right, this bottom one, the bottom number, right, this event right here, the number of things, it becomes our sample space, right? So the number of things in S9, right, is going to be the bottom number here. So that's 1, 2, 3, 4 things, right? So the bottom number will be 4. All right, and then the top number, right, is going to be the number of things in R1 that are also in S9, okay? And you can see there's none, right? They're all completely separate. Okay, these events are mutually exclusive, right? R1 and S9. Is it possible to roll a 9 as the sum and also at the same time to roll a 1 on the red die? And the answer is no, right? Because the highest you could get would be a 7. You can't roll a 9 if you roll a 1 on the red die. All right, so these events are mutually exclusive. So the number of outcomes that are in R1 that are also in S9 is 0. Okay, so that would be our top number here. And 0 divided by 4 or any other non-zero number is just 0, right? So the probability comes out to be 0 on that one, meaning that it's impossible, right? That can't happen. Okay. All right, and that is it on that example.